Annals of GIS, actually, Professor Hui Ling was the founding editor of this journal. Currently, he's the honorary editor-in-chief of the journal. And this journal currently is in the ESCI index, so by Clarivate group. So it is actually basically a paper you publish in this will be indexed in Web of Science and be counted in your H index. So it becomes a major journal. And recently we have a agreement with Nanjing Normal University for 5 years project to turn this journal into open access journal, and it's free to authors. So in a 5-year project, so all papers published in this journal since the beginning of 2019 will be available free to all authors. So now papers in this journal is actually much wider circulations. The journals recently, we expect this year with the impact factor would be called the mark impact factor would be a 2 or 2.5, that range. So it's actually having a lot of citations. So we have some interesting paper, many interesting paper, including the ones presenting today is publishing. So without any further ado, I'm going to turn over to invite Professor Lin to giving a welcome remark. Right.
Hello.
Professor Lin, yeah.
Yeah, can you hear?
Yes, we can hear you.
Okay. Thanks, Professor Zhu. And I'm very honored and glad to have a chance to hear to say something, actually. And the journal was organized and developed by many friends in last about 20 years, right? We worked together to promote the academic development in the field. And actually, at the beginning, we would like to have this journal as a bridge to bring in, friends, scholars, especially young scholars, as in this field, to work together. So in the last 20 years, we have seen so many friends, put a lot of effort to develop this journal, include many friends in China and other parts of the world. I think, especially under the leadership of Professor Zhu, we can see the last years the development and very quickly moved to more health status. I think this also we should thanks the contribution and support from Nanjing Normal University and also friends and in the editorial board, especially for the executive editor group in Nanjing Normal University. We also, I think I would like to use this opportunity to thanks all this the authors of those papers submit to our journal. Here I would like to congratulate all award winners for their great contributions to our journal. I hope that their examples will followed by many other friends and scholars in our field to make our journal better and better. Here, I would like to. I hope next year, since we are the organizer for CPGS conference next year in Nanchang, I hope we have the chance to meet those authors or other friends in our conference, we can. I have a chance to the hoster to thanks all of your contribution to this journal. And of course, our hometown is a very beautiful town. And I hope we have a chance here to show the ability of our team here. And then we can have a better understanding each other and work together for the future of our journal. Again, thanks Professor Zhu and the team, and editorial, and all the reviewers, all people, work for this journal. And thanks all these authors for their contribution. And again, congrats to all winners, and hope to see you again somewhere. Okay, thanks.
Thanks, Professor Huiling, and thank you for your support and funding effort made this possible, and also your continuing effort in promoting this journal, non-journal, or the other activities that relate to the group, the CPGIS organization. So also before I invite the president-elect for the CPGIS, but I want to take this opportunity to recognize the people who are contributing to this event and also to the journal. So I will ask any associate editor, executive editor who currently online to turn your video so I know who you are here, who's here, because it's difficult to flip through the list. So first of all, let me recognize Dr. Suming Bao. Now he looks like he flips through the list of participants. So he looks like one of the good old broadcaster in the U.S. or in European. People from Europe, you watch soccer games, and he looked one of people like that. And if you people in North America, or China, you probably watch some basketball teams play and some of the broadcasts. So Professor Bao, say hello. Could you say hello?
Hey everyone. Yeah. Good morning, good afternoon, good evening.
Okay. Then we have, I think Min Chen is here, right? Yeah, Min Chen here. So could you say hello?
Yeah. Hello everyone. Yeah.
And let's see. Yeah. See what the other editors, associate editors here. Anybody else?
This is Xun Shi from Dartmouth College.
Xun Shi, yeah.
Hi, I'm here.
Yeah. Professor.
Go ahead. Sorry.
Professor Chen Min is the executive editor, and Professor Xun Shi is associated responsible for the GIS and health, and also saw Professor Song from University of Wisconsin-Madison, my dear colleague, a young star in the field of GIS, and he's in charge of GIS and spatial big data, right? So who else is here? So I see three of the editors. Okay. So anyway, without further delay, I'll invite Professor Zhizhen Wang from the University of South Carolina. I apologize. Hopefully you forgive me because it's a really late in the evening, early in the morning in China. So my pronunciation is not going that well. So she currently is the president-elect of CPGIS. Will be sworn in a little earlier than Joe Biden. He will be sworn in. She will be sworn in January 1st. Biden will be January 22nd, 20th. Okay, so we're ahead of Biden. So, right. So I will invite Professor Wang to, or President-elect Wang, to giving a introduction to the awards that we have, and then to the organization CPGIS. Professor Wang, please.
Yeah, thank you, Dr. Zhu. And thank you for positioning me in such a high level there. Good morning, good evening, and good night to everyone in the meeting. And my thanks to China Data Institute and Future Data Lab for co-sponsoring this exciting event with CPGIS. As Dr. Zhu introduced, I am the new president for next year, so a little bit early action right now. I'm honored here to give a quick overview about CPGIS and also the streamline of 3 journal paper awards from Annals of GIS. Very quick. So for CPGIS, Chinese professionals in geographic information sciences is an international association and to promote GIS science in research, education, and professional development for its members all over the world. CPGIS was established in 1992. The purpose was to serve as a home to all Chinese professionals in GIS field. And now it has expanded much broader, much deeper. We have more than 200 active members, and we are open to all people who are interested in the GIS science world. Dr. Hui Lin actually is the founder member of CPGIS, and also Dr. Zhu, Dr. Bao, they are excellent past presidents that gave me huge support here. I also noticed a good number of names in the participant list. They are also very active CPGIS members. My thanks to you for the support. For the journal, go ahead. Is that me? Okay, quick introduction about the journal. Annals of GIS is the flagship journal of CPGIS. Dr. Lin already made a great introduction about the journal itself. So I'm going to focus on the 3 journal awards here. Starting from this year, actually, 2020, the journal starts to routinely offer 3 awards. Best Paper Award, Most Downloadable Paper, and Most Cited Paper. My apology. The Best Paper Award is a CPGIS award, basically. It's an annual award, and the selection is a joint effort between CPGIS Award Committee and the journal's associate editors team. The selection goes through a formal procedure of nomination, evaluation, and final selection. And the meeting today is a kickoff event, if I could see here, featuring the 3 best paper awards selected from the AGIS publications in 2019. So that's the basic information about Best Paper Award. The last 2 awards, Most Downloadable Paper and Most Cited Paper, that's based on the publisher's records. The Most Downloadable Paper is for 1 year. So very soon, you will see the announcement of the award winners for 2020. The Most Cited Paper is a 2-year selection. So it will be based on the citing record in 2019 and 2020 for the soon coming award. Some other information for the timeline. Except this kickoff event right now in December 2020, from next year, 2021, all three awards will be released and announced in the beginning of the year. So in early spring 2021, I will expect the announcement of all the three new awards for 2020. Okay. That's all about the three awards. I think this concludes my introduction on CPGIS in general, and also the three awards from the Annals of GIS. And again, I thank the support from the journal and also the support from China Data Institute. Mr. Chair, now I turn the time to you. Dr. Zhu, if anyone has any questions about the journal award, probably you can put it in the chat room so we can follow up later.
All right, great. I just I muted myself, so I was speaking to no audience at the time. Well, thank you, Professor Wang, for the introduction to the awards, and for all of you, starting this year, we're gonna have every year we have three awards beyond three kinds of awards to be announced. So each type of award would have three papers. So please stay tuned and watch out for those awards. And so now we move into the meat of today's event, and which is what people are expecting, looking forward to hear. So we go into the order from third place paper to second place to first place. So we invite Professor Yunqiang Zhu, who is the researcher at the Institute of Geographic Sciences and Natural Resource Research, the Chinese Academy of Science. He and his colleague published a paper called Automatic Data Matching for Geospatial Models, a new paradigm for geospatial data and model sharing. So Professor Zhu, here you are, please.
Okay. Thanks for Professor Zhu. Because the connection is not so good, so I will turn off my video. Okay. And
share your screen.
Yeah.
Yeah.
Good.
Can you see my presentation?
Yes.
It's coming right
now. Is
now.
Okay?
It's coming. Yeah.
Okay.
Yeah.
Yeah. Okay. Hello, everyone. So, good morning, good afternoon, and good night, all of you around the world. It's our honor to be one of the best people of 2019 Annals. We are grateful for giving us this chance to take the presentation to introduce our research. Okay, firstly, I will give you the brief introduction of our research. So, as you know, after 3 stages development, now scientific research is in the fourth paradigm, that is data-intensive paradigm. In this paradigm, we usually use big data processing and simulation models to mine and analyze massive scientific data for discovering scientific law and problems behind the data. Yeah, for geoscience, it is a typical data-intensive research, which is a cycle and continuous improvement process from collection and observation to analysis and interpretation, and then through conceptual and numeric model validation and production. So geospatial and models are two basic elements or core resources used in geoscience research. Geospatial data is the objective record that describes the attributions and the characteristics of geographic entities and phenomena. Geospatial models are the effective tools or methods used to recognize imperceptible geographic phenomena and forecast the development trends in geographic process. Okay, we noticed that recent decades geoscience research has moved from qualitative to quantitative methods, a local to global scope, and single factors to multiple factors. Since geospatial models are becoming more and more comprehensive and complex, preparing larger amounts of import data is a really time, labor, and money-consuming task, which has become an obstacle to the application of geospatial models. So, and the methods of preparing import data for geospatial models have undergone the 3 stages of completely manual, web search based, and semi-automatic matching. This table shows the features and shortcomings of the completely manual, web search based, and semi-automatic matching methods. It's obvious that they all fail to achieve fully automatic matching data for geospatial models. On the other hand, with the development of Earth observation, ground-based exploration technology, and volunteered geographic information (VGI), the ability of acquiring geospatial data has become great. The amount of geospatial data has increased explosively, and the most of the data is open and freely shareable online. We can use this online open data by data portals such as WDS, World Data System, and GCMD, all the latest open data form, like data journals such as Earth Systems and Science Data Journal. Okay, so we are thinking that it's possible to use GIS online open data to automatically match to geospatial models. That is the background of our research paper. But some key issues need to be solved. The first one is that the import data of the geospatial model is inconsistent with the description of the open geospatial data, and they are heterogeneous in structure and semantics. So how to describe them uniformly? So this is the first key issue. And the second one is that geospatial data has multi-dimensional features such as content, time, space, attribute, structure, format, and how to develop the best similarity algorithms to compare the online open data and the requirements of import data of geospatial models. The third one is that how to difference between data to entirely meet the requirements of the geospatial models. That means the open data completely meet the important requirements of geospatial model and can be imported into the model directly. The basic idea of fully automatic data matching is shown as this equation. You can see here. And we are in this equation, the SD is the open online data, TD is the import data of geospatial models, and FS is a similarity calculation function between F and the TD. FP is the data processing function. So in this equation, if the similarity Fs equals 1, that means they are fully matching, and the data can be directly used to the model without any processing. But if the Fs equals 0, it means they are entirely not matching, and SD cannot candidate data for the model whatever processing is done. Okay, and when Fs greater than 0 and less than 1, it refers to they are partly matching, and the extra processing is required to SD. That is our paper point. And based on the basic idea, the framework for automatic matching data consists of 4 steps. The first one is to know each other, and the second one to measure their similarity, and to know the difference, and to become the same. Okay, correspondingly, at first we need to use unified data description factors to describe the online open data in import date, and then calculate their similarity and precisely identify their differences, and finally automatically process the online open data to eliminate the difference. So as I mentioned above, unified description factors, UDFS, is the basis of automatic data matching for geospatial models. As you see in this picture, okay, in this picture, different models use different standards or interface to describe their import data requirements, and the different data portals publish their data using different metadata standards. So we need unified description factors to describe the online open data and the requirements of the geospatial models. Okay, so we analyze the application process of geospatial models and the 2 forms of their import data requirements that are static and dynamic requirements. So from okay, to the operation of a geospatial model. And also we analyze the process of the online open data discovery. As you see in this picture, firstly, it focuses on if such as content and the spatial coverage, temporary coverage, and underline the morphology features matching degree, like data type and the data format, data datum, and line the similarity of semantic features like the unit and the classification system of attribute fields. Based on the above analysis, we UDFS. This table lists all UDFS, which contains 22 factors of 3 types. Using UDFS to describe the online open data and the requirements for the import data of geospatial models, we can build the bridge between them and compare them and calculate their similarity. In practice, we use XML to express UDFS to make the descriptions understandable and processable to computers. After the open data your models have the uniform description, we can further calculate real data similarity, which includes a single similarity. You can see here, and compound similarity and the overall similarity. Generally, the compound and overall similarity is calculated by using AHP method based on several or single similarity, and the single similarity calculation methods may be really different and complex for different data features. Oh. This slide shows the content similarity calculation algorithm, which includes theme similarity calculation and category similarity calculation. Spatial similarity calculation covers the spatial topology and spatial distance or area proportion calculation. The similarity is given to 1 when spatial relationship is equal, like here, and while the similarity is set to 0 when the spatial topology relationship is disjoint, and the similarity is greater than 0 and this than 1 if the spatial topology relationship is contained and in section, region, patch, and real exact value are determined by the spatial distance or area proportion, like here. Like spatial similarity, similarity also includes temporary topology and distance calculation, like this slide. And generally includes a spatial scale for vector date or resolution for raster date and granularity factors. As you see in this table, they are measured mainly based on the conversion difficulty degree, and the similarity is higher when the spatial scale resolution or spatial granularity conversion is easy. The first table shows the value low of spatial position similarity, and this table shows the value low of the temporal granularity similarity. And this slide introduces the data table similarity and the data format similarity algorithm for different family format. Real similarity are measured according to the openness of formats. The detailed information is shown as this table, because it's easy for the same data format family, and so we just give the similarity by experience. Where after all single similarity are calculated, we can calculate the compound similarity of all similarity by AHP method. This table shows the weights of all factors by expert scoring method. And After the similarity calculation, it must precisely record the differences between the open data and the import data of geospatial model. That includes two parts: the quantitative similarity and the semantic matching sets, as you see in this equation. The second part compresses the matching relations and extent, which precisely record the differences. The key points in the precise expression of the data matching results are a clear matching relation and detailed matching extent. The former decides what processing will be carried out on the candidate data, while the later determines the scope of the candidate data to be processed. And this is a XML-based precise expression of data matching results that should be understandable and processable for computers. This is an example of how to precise express the matching result. And based on the above precise expression of data matching results, one of several candidate data and corresponding data process service will be automatically selected and smarter assembled to form the specific data processing service chain to automatically process the open data until all requests of the model are met. This picture shows the workflow and shows the mapping between matching relation types and data process functions. And you can see the spatial topology relation. The use spatial pin and spatial merging function to deal with the spatial data. Okay, and in the entire data automatic process, data process service repository need to be locally developed in advance. All real-time coexisting web open data process service in real time. Moreover, GIS must adhere to OGC WPS, otherwise it's difficult to assign face and semantic. The data processing services structure based on WPS, and we use the PY-WPS framework to implement the data processing service smart combination, and the detailed process service are developed by using some open source GIS libraries like GDR, OGR, and GeoTools. And we also do the case study, and we take calculating the 2000 to 2010 soil and water loss for Guizhou province by using Russell model as an example to test our methods. This is the Russell model, and this is the UDFS of import data, one of the import data P of the geospatial model of Russell. And the National Earth System Scientific Data Sharing Platform of China as open data source in our case start. And based on the similarity calculation result, we got the best candidate dataset of the data portal for the raster application. That dataset is 2000 to 2010, China 1 kilometer annual rainfall raster dataset. This is the best candidate dataset for our application. And then we make the precise expression of matching results of the best candidate date and the import date of raster. There are two differences between the candidate date and the import date P. The spatial coverage, because our application is Guizhou province, but the candidate date, the spatial coverage is China. Okay, so the first difference is the spatial coverage, and the second is the data format. And the corresponding processing service, spatial clapping and the format transformation are selected, and then the candidate date is automatically processed in order. The left picture shows the process work picture is the data processing result, which totally meets the model's requirement. And we're using the spatial clapping and to get the Guizhou province and using to get the format, the model needed. Okay, finally, some conclusions and discussions. And in this paper, at first, we propose a framework of automatic data matching for geospatial models. The framework can not only automatically and efficiently match import data for geospatial models, but also further improve the sharing efficiency of open online data, and then put forth unified data description factors, which take into account the characteristics of data source and the requirements of geospatial models calculation, and forms a relatively well-performed data similarity calculation system. And also we propose approach to construct a smarter assembly data processing service based on precise expression of data matching results. The approach can automatically select the corresponding data processing service and the processing region according to the data matching difference. So in the future, the unified data description factors should be further improved, and the more accurate similarity calculation algorithm suitable for different factors is still the focus of our research. Also, building a data processing service repository that can handle all kinds of differences or sharing existing data processing service in a unified semantic sphere is our future research direction. And finally, at present, the data processing services are combined one by one according to the order of matching factors. In fact, there is a certain logic between data processing service, which is different due to the difference of single data processing and the combination of multiple data processing. Therefore, we will consider the data processing service and composition optimization in the future. So in the future, actually, we really hope our research will be promoted the integrated sharing of geospatial data model and computing to support the construction of e-geoscience. Okay, that's our presentation. Thank you very much.
Thank you, Professor Zhu, for the
Oh.
interesting presentation. Your work does present a very interesting prospect for the future for us to be really free of finding data for models, potentially for ordinary citizens be able to participate in scientific computation modeling without too much hurdle in finding the data set. Okay. So without any further ado, I would ask, we still have some time for questions, about 5 to 7 minutes.
Professor Zhu, I'm online.
Can you hear me? Hello?
I can hear you. Yeah.
Oh, did you hear what I said earlier? Right after your presentation? Professor Bao, can people hear me?
Yes, I can hear you.
So did you hear my comments on
Yes.
on the paper? Okay, good. So as long as people can hear that, great. We have a little bit of in the presentation, we have a little bit of a delay. I think it's probably related to network from the Chinese Academy of Sciences. But anyway, so any questions? Xuan, go ahead. You have a question? Looks like you have a question, right? For people who will ask a question, please turn on your video so we know, and also say where you are, who you are. Okay, so go ahead, Xuan.
That was, yeah, I was put on the spot of like, yes, indeed, I was thinking about some questions. I'm not sure if I do have formalized the. Anyway, thank both Professor Zhu for organizing this session and give a great presentation. I think Professor Yunqiang Zhu's the paper or the presentation is really inspiring. I think this is really a good idea as we are entering a big data era, and many geoscientists are using models, and there's just too many data out there. And if we do have a scheme or a mechanism that can, using the current contemporary technology, to help us to select data, search for data, that'd be really helpful and great. And when I was listening, I have these two things came to my mind. One is that it seems this process it require not only this comparison or this searching scheme on, say, our local machine or on our modeler researcher. It seems that it requires a very structured organization of all the data online so that these methods can work. So it seems to need a very good standardization and applied, and every data provider adopt certain standardizations and to make their data archives or repertoire or the databases to follow certain standards so that this process can work and apply. This is one thing. I don't know if Professor Yunqiang, do you have any idea or any thoughts in that kind of standardization, international, global-wise, the standardization of all data providers? That's I would say that would be a great data infrastructure construction. That's one thing. And another thing is, Professor Yunqiang Zhu went through a very detailed, very concrete the spatial similarity comparison. I'm not sure if, say, when you are automatically match the data, are you going to apply this procedure from the topological comparison to the temporal comparison to very detailed comparison to all the data you search? I imagine that would take a very intensive process to do this comparison. I'm not sure if that's really feasible in practice. So that's my two issues.
Yeah, it's really good questions. So actually, your two questions is key points of our masters. So for the first questions, right? We because you know and different data portals they use different standards to describe real data. So we need before using our
You are breaking up, Professor Zhu. You're breaking up. So
yeah.
Okay.
Could you
repeat? Okay, good. Better now. Go ahead. Hello, Professor Zhu there? I think we think
we can have a discussion afterwards. I think.
Yeah, we can have
because those are really not short questions or quick questions. Yeah.
All right. All right. So maybe we can kind of we certainly the paper is online, and then you have a you can certainly contact Professor Zhu for discussion or hopefully maybe possibly collaboration. So maybe for this presentation, we stop here, but the conversation continues offline. Okay, so which is nice. You have a open access journal that you can get the paper for free, and then now you know the general idea of the paper's about, so you can get into details. All right. So great. Thanks, Professor Zhu, and then I give a round of applause for this. And we're going to move on to the next paper, which is the second place best paper by Dr. Badia and Mashkudi, who's the assistant professor from the Environmental Science Group, Wageningen University, the Netherlands. The title of the paper is Spatial Homogeneity and Heterogeneity of Energy Poverty and Neglect Dimension. Welcome, please.
Thank you very much, Professor Zhu. I just shared a PowerPoint with you, and I hope that works good. Do you see my screen?
Yeah, it is. Yeah, it is.
Yeah. Perfect. Thank you. First of all, I want to thank you and thank the committee for selecting us. It's really an honor for us. I'm Badia Mashudi. I'm from Department of Environmental Sciences in Wageningen University. But actually, I'm presenting on behalf of a group, so I should also introduce the co-authors. It's Professor Dominic Ested from Aalto University. Professor Ested is a professor of land use and transportation planning. Also, Professor Arjan van Timmeren from TU Delft University. He's professor of environmental design. When we wrote the paper, actually, I was a PhD in TU Delft, and also Professor Ested was an associate professor in Delft. So these two gentlemen were the promoters of my PhD. So, but later on, everything changed, and so now we're in different institutions. As you mentioned, the title of the PhD, the article is Spatial Homogeneity and Heterogeneity of Energy Poverty. Energy poverty, Netherlands has a very strict policy for the energy transition, as well as a European Union. In Netherlands, there's a very ambitious policy to phase out gas use for the houses for space heating and cooking before 2030. The matter of fact is that, as you can see on a left image, gas has a very large share in the energy basket of Dutch households. The reason is that Netherlands has its own gas fields, so it's not dependent on importing gas, and gas is cheaper, and there's a very large network of gas. So therefore, use of gas is very large. As you can see on the right image, it's making sense that because gas is really making a lot of emissions, so cutting it out is absolutely an important idea. But because given that it's very cheap, the energy expenditure of the many households may raise sharply, and that will end in energy poverty. That is, in a broad definition, is that the burden of energy expenditure on a household budget. So that's the danger. That's the societal relevance behind this study. But yet, as far as there's a very strict and clear policy about energy sources, among them gas, there are some very big gaps in the policies and in the knowledge on the issue in the Netherlands. First of all, there's no clear definition of energy poverty is not in none of the policy documents. And there's only the energy vulnerable households are acknowledged in the policies, and those are the people who couldn't pay for electricity and gas. The company cut out their access to energy, and they are in a life danger, so they may really freeze in the winter. So only these people get support from the government, but there's no other definition of the energy poverty. That and we find it really poor protection for the consumers. Secondly, energy policies in general. Back then, we wrote this article, and even today, but given that we wrote the article in 2018, are one size fits all. There are policies that are supposed to fit to all the areas, regardless of for whom these policies, who are living there and what are the conditions, environmental conditions and social conditions. And there's a very big lack of studies, scientific studies on energy poverty. And the research questions that this study put forward was that, and the bigger question was that, what are the determinants of energy poverty, first of all? What are the spatially homogeneous determinants of energy poverty? Meaning that the factors which are in force everywhere. So the factors which we can generalize for all the Netherlands, and we say, okay, these are increasing or decreasing energy poverty. But what are the especially heterogeneous determinant of the energy poverty? Meaning that the factors which are in force only in some specific areas, and we cannot generalize it to all the country, but there are some, in some local areas, they are matter of big importance. And the reason for asking these questions is that the first answer to the first question would help the national level policies, whereas the answer to the second question can help the local scale policies, municipal and provincial policies, given the very diverse and multi-scale politics and governance in the Netherlands. And to do so, we started to map the data of energy use. We had a very luckily very precise data over the consumption of gas and electricity in the Dutch neighborhoods, which are definitions. The boundaries are the institutional boundaries that the Statistics Bureau of Netherlands defined them. There are over 2,500 neighborhoods in the Netherlands, and we had the data there. We had the data over the annual gas and electricity consumption. We also had the data we knew over the price, and we also had the data on the income of the residents of these neighborhoods. Actually, that's the most fine scale that you could get the data on the income of the residents. More fine scale than this is a matter of privacy, and it's not open to public, the data. So we come with this calculation that how many percentage of the residents' income goes for the energy expenses. And as you can see, if you look at these different deciles, it could be quite diverse. So this number can, well, in a very extreme situations, can get as big as 15%. But it changed between 1 and 5%, we can say. And we put this as some sort of a continuous definition of energy poverty. We said that more is that this percentage, we assume that more is the energy poverty. As you perhaps know, there are different definitions. There are some countries say more than 10% is in energy poverty, less than 10% is not, or something. We didn't want to put this type of a thresholds. So this we use as an indicator of the energy poverty. On top of that, for all these neighborhoods, we start to put some potential factors which can be related to energy poverty. We have a household size, of course, that it has a big effect. We have a privately rent houses, the percentage in each of these neighborhoods. Low income are the people between the 40% of the lowest income of the country, the percentage in a neighborhood. We have unemployment percentage, pensioners in percentage, building age as a proxy for the building quality. That's in all the country, we could not get closer to that. We also had a number of summer days. That means that the days that the maximum temperature exceed 25 degrees. And number of frost days means that a number of days in that neighborhood that minimum temperature went below 0 degree. So these are the independent variables of the study. And on top of that, we just conduct the geographical variability test. The test is developed by the Nakaya. The tool is GWR4, the name. The test is based on carrying out a series of geographically weighted regressions, and each time it put out one of the variables, and so have a fixed coefficient for one of the variables, and the especially variant coefficients for the others one time, other time especially variant for all of them, and compare if the performance of the model improved based on this process or not. If it was improved, it's considered to be a heterogeneous variable, and if not homogeneous, so it just tells us which ones are really have a especially variant coefficient and which one are not. This comes to this kind of a result. We got to know that there are two groups that everywhere in the country, in any neighborhood of the Netherlands, are similarly exposed to energy poverty. So presence of two groups everywhere contribute to the energy poverty, regardless of all the other geographic circumstances. Those are the people with low income and pensioners, so wherever they are, with a fixed coefficient. But there are 6 others that they have a different, depend on where they are, they could be endangered by energy poverty or not. So that's really depend on the other local circumstances. This is the household type, the ownership type, the unemployment, and the climate variables. If I just want to map the coefficients of the different type of the determinants, the homogeneous and heterogeneous ones. Homogeneous ones are just red lines because we just have one coefficient for everywhere. And then the heterogeneous ones are showed by this box plots because they are changing across the different neighborhoods. And then you can see that, for instance, the percentage of low income has a very solid and high impact in general, but sometimes also it could be, for instance, it could be overshadowed by the climate conditions. Or it also goes to the number of pensioners. Something such. I should just say that the box plots are only the significant coefficients, not all the local coefficients. Here I just start to we just start to map only the local coefficients, because the heterogeneous coefficients, given that homogeneous ones are always fixed, always the same. And then you can see that the impacts are different in the different areas. For instance, you can say, for instance, in the north of the country, private rental houses are just causing more of energy poverty, are associated with higher levels of energy poverty, rather than in the southern part or something like that. So we have all these 6 local coefficients, yet it didn't serve properly. It's good for the prediction, but just we needed one level of more simplification that is get more understandable and communicatable to particularly the policymakers. So we start to look to every neighborhood, and we just map and show the largest local coefficients. If we do that, we come to this map. This map shows the largest localized, specific to that particular neighborhood coefficient, significant coefficient. And as we can see, for instance, household size has a big, in a majority of the cases, household size, meaning that the households with children or multi-generational households are in danger of energy poverty. But also when it comes to the most urbanized part of the country, we can see the privately owned, that typically are the houses which are, these are the, well, you could say urban ghettos, are really in danger because they are not properly renovated, the private ones. There are areas that, for instance, you can see the climate has an important role. When it goes to south to some parts, for instance, the warm days are really triggering energy poverty. Most probably those areas can also overlap with the age groups or something as such. But altogether, we come to this point that we have these generic groups that everywhere should be supported. And those were the low-income pensioners. And here is that the most vulnerable group in different areas of the country. This comes to 2 types of the conclusions. That first of all, the policies should acknowledge the location-specific situations of the energy-poor neighborhoods and start to think who is really the most vulnerable as such. Also, on top of that, policies, instead of taking a look, so they should have a location-specific and not only the one-size-fits-all approach. And on top of that, they should take a look to what was the geographic condition which can bring about energy poverty, rather than just to think about the cause of it, rather than just wait for the effect when somebody is freezing because of having no energy and come to an end. And it's interesting that this article was written in 2018 and submitted and published beginning 2019. In June 2019 came a new policy, not a policy, a vision in Netherlands, a climate accord. And actually that vision really endorsed the outcome of our article. Our article was that it shouldn't be one-size-fits-all approach, and we need some national but also local policies. Then the new vision urged for this kind of approach, and they call it a neighborhood approach, which is a scale that we use. That in the vision comes that every neighborhood should find its own specific solutions to the problems. And also we don't claim any causal relation, but we are happy about these endorsements, so to speak. Thank you very much for your attention.
Great. Thanks, Professor Mashiri, for the interesting talk. Your talk is really exemplifying the role of geography in policy making, and this is an excellent example that we can demonstrate not only to geographers but to the policymaker that how important geography it is, right? So this is a very interesting talk. Thank you very much. So we have plenty of time. We have about 10 minutes to discuss it further. And then I would ask our presenters to turn people who are questioners to turn on the video, okay, so that also say who you are and also be brief on the question so that we can hear the answer from the author, right? Questions, please.
Or maybe I can have a question here.
Yeah, sure.
It's a very interesting articles and also very good solid geospatial analysis. What I'm wondering is the indicator for this consumption, energy poverty. So if you look at the literature, there's a different kind of the measurement of energy poverty, right? For the energy consumption, the poverty is there. Probably there's at least you can classify it as one essential energy consumption or optional energy consumption. So therefore, essential energy consumption, that's necessary for everyone, every household. Then the optional energy consumption, that considered as luxury, the consumption. So that's you probably need to, if you talk about the poverty, the energy poverty, what do you probably will mean the essential energy consumption, right? So that's number one, and how you to differentiate the two different consumption. The second one is what kind of the base indicator for this energy poverty. So this energy poverty is the percentage of expenses to their disposable income, or should be kind of energy consumption by per person, right, or per household. If you use energy consumption by per person or per household, the more energy consumptions probably will mean the more optional consumption, energy consumption. The lower the percentage or of the energy consumption per household per person, that means probably the highest degree of energy poverty. So I just wonder, this might be, have some impact on your results.
Well, thank you very much for your question. Actually, this is very, very good and very relevant questions. We had also these discussions. And when it comes to the essential and to the optional energy consumption, well, I can make two different type of reactions to that. First of all, is about the data availability that what we had. So when it comes to, given to the scale of the study, we could not know more that what for the energy is consumed. So knowing that can be done if there's a sampling of the people and then in detail a study of the consumption. Here we possibly didn't have access to this level of data, that what the data is used. For instance, if we knew how much of data is for space heating or how much of the data is for cooking, that would really be helpful. And then that was the main reason. But also sometimes that may be hard to say what is essential and what is optional. Imagine an elderly of 80 years old, which has a problem with moving and cannot really go out of the house, and therefore spend a lot of hours to watch TV or talk on Skype or something like this with the families. I have difficulty to call it optional or essential, given that how it's important for the mental health of that person or as such. I agree with you that this is important to take a look to more detail what is going on. But I would say it first of all, it's difficult to come with the definition, and secondly, we had a matter of scale. The definition that we use for energy poverty, as again you correctly mentioned, Here, what we used was a percentage of a disposable income after tax per person. So we had the data income, disposable income per person, and we use a percentage of that. Of course, that's a matter of discussion because, for instance, we know that, for instance, in many countries, 10%, more than 10% is called energy poverty or not. In UK, there's a dual definition or something as like. Given that in Netherlands there was no definition, without that any definition that we come with that impose some impact on the result, so we just try to come with this kind of some sort of continuous measurement rather than a binary measurement, that who is in energy poverty and who is not. But overall, I agree with you that this type of a discussion would enrich the studies on energy poverty.
Okay, great.
Great.
We have
Thank
still time for another one, 2 questions, depending the length of the question, also the answer of the question as well. So any other questions? If not, I have one actually.
Yes, please.
So it's certainly great to see this spatial heterogeneity and also have a policy accounted for this kind of spatial heterogeneity. But what spatial granularity or footprint we're going to resolve that? For example, in Netherlands, you might have a gentle rolling hill slope, flat, reasonably flat. So probably this kind of differentiation in spatial heterogeneity can be applied to a city or county level in Netherlands. But if you're in, say, in England, you know, the landscape is quite diverse, and the solar radiation complicates that quite a bit. So should they be kind of account for this heterogeneity and very finer spatial details? Do you give a thought about that at all?
Well, that's a very, very good question, Professor Zhu. And actually, I personally like the way that you approach these issues on your writings. Well, the very, very honest answer is that here, why we use these units, neighborhood units, is because of data availability. Mm-hmm. That's the best data we got, and at this level of scale. So, if it was some heterogeneity inside these neighborhoods, we could not really go further. But thankfully, Netherlands is very flat and not very quite uniform. But in general, I acknowledge the importance of that. So I imagine it should go down to a level that is start to got to some atomic, so to speak, spatial units. The spatial units that we can assume internally are showing some properties. For instance, if it was about the solar radiation or different shade of the hills or something like that, it should go as small as possible. But
well, what I'm coming from, sorry to interrupt, I'm coming from the policymaker perspective, not from GIS analytical perspective, whether we're limited by the level or detail of the data that we have. But for policy planners, they may not be able to devise a policy at household level. So what would it be? I mean, I'm interested in what kind of spatial granularity that you'll be able to be able to consider at the policy maker perspective. This is a very interesting issue. I want to hear your thoughts on that.
For instance, the thing that we are thinking here, that how policy can get to this level, is that on the energy bill, the energy bill has 3 components. And one of them is for the energy per se, one of them is for the network provider, and one of them is a tax. So everybody pay an energy tax of up to 20%, and it's the same for everybody. Policymakers, given that they have a data at the individual household level, can make this tax smart and change it neighborhood to neighborhood for the different type of people. So it could be some tax relief for big families on rural areas, whereas the tax relief in this particular urban area goes to the rental houses, or to this area goes to some other people. So given, I think ICT is the answer. ICT and the big data that the governments have may help to just have a really policies tailored at the individual level, and help to do so. So that would be, I would say, the smart tax, for instance, would be one of the solutions.
Great. Thank you very much.
Thank you for your question.
Appreciate it. It's a very interesting talk. And then
Thank you very much.
good. Again, for people who have further questions, you probably could follow up with Professor Mashoudi offline, and then certainly get more interaction with him on that. So thank you again. So we're moving on to the next paper by Marha and Kalnick and her colleagues. So Marha, okay. I think is that right? It's Marha, right? It's not Marha. Marha is pronounced as H. I always got myself confused with H or J. So I apologize for that as well. Great. So her talk would be the paper is the first place best paper in the best paper series. Her paper title is Fuzzy Inference Approach in Traffic Congestion Detection. Now, some of my colleagues might know that to say, hey, you editor-in-chief may have some role in this first position paper because you do fuzzy logic as well. Well, my fuzzy logic is very different. So this paper earned the first place by its own merit, has nothing to do with what I do. Okay, so I want to disclaim this. Okay, here you go. Please go ahead. Forgive me. Mara is a research assistant from the Department of Applied Geomathematics, University of Augsburg, from Germany. So here you go, Mara.
Thank you very much. Well, I wanted to greet you all again with good morning, good afternoon, and good evening. But I think this changed in between time since we're already an hour and a half talking. So I would say hello to everyone. And before I start, I might ask, do you all see my screen?
What was that? We didn't hear. I didn't hear. What the last one?
Yes. The question was, do you see my screen? Yeah.
We can hear you. We can hear you.
Okay, good. Great. So first, let me express my special thanks to the Annals of GIS editorial board, as well as the award committee of CPGIS for awarding me with the Best Paper Award for 2019. Then also, I would like to thank you, Professor True, for informing me about this award, as well as Dr. Bao for guiding me through this process of participating in this event today. And last but not least, many thanks to China Data Institute and the Future Data Lab for organizing this event. And before I start with my presentation, I would like to say a few words about myself as well. So my name is Maya Kalinic. As you already said, I'm the PhD candidate at the Department of Applied Geoinformatics at the University of Augsburg, which is located in Germany, exactly here. And my research interest, as it's already seen kind of from the title of the paper, goes towards the fuzzy logic, fuzzy inference systems, and adaptive neurofuzzy systems. The second portion of my research interest goes towards traffic analysis, most specifically traffic congestion, detection, and prediction. And last but not least, in the direction of floating car data as an alternative method of collecting traffic data. As usual, I'm not the only one who is working at the geoinformatics group or geoinformatics department in Augsburg. This is the two teams that we have here. So the team on the left side is the team geoinformatics with the Professor Tim as the team leader. And on the other side, we have applied the geoinformatics team with Professor Yuka Crisp, who is at the same time my co-author on this paper. And finally, let's hear some few words about the paper itself. So the paper is called Fuzzy Inference Approach in Traffic Congestion Detection. So my idea was to first explain some basic terms that are already seen in the title, but that are going through the paper constantly. So the fuzzy logic. The fuzzy logic, as its term, is being for the first time introduced in 1965 by Professor Lotfi A. Zadeh. Professor Zadeh thought that the key elements of human thinking are not numbers, but rather labels of fuzzy sets. And he thought that there is an option of teaching or trying to teach the machines to think as humans. And if that would be possible, that would mean that it would be possible also to model any type of phenomena which have or which has human interaction involved. So the basic idea behind fuzzy logic can be explained with this simple set of elements here. So if we imagine that X is the set of elements, in crisp logic or in binary logic, we would say that, for example, A either belongs to this set or it doesn't belong. So if it belongs, it will get the value of 1, or if it doesn't belong, it will get the value of 0. So quite clear and straightforward. But in fuzzy logic, we would say that this A belongs to a certain degree to this fuzzy set of A, and that each element of this set X, so any of these, belong to a certain degree of membership to this fuzzy set that is within the set of X. And this degree of membership is, in other words, called membership function, and it's being explained as the curve that basically describes to which degree any element belongs or does not belong to the fuzzy set. And that's all on this closed unit interval from 0 to 1, and not just 0 or 1. So there are different types of membership functions. Here I'm showing you only 3. Which are called triangular, trapezoidal, and bell-shaped. Obviously, the name comes from their shape. And these functions are based, of course, on the data and the data distribution. In traffic analysis, the reason why I'm showing only these 3, because in traffic analysis or traffic data, those are the most common ones to encounter. However, in some other types of, or in some other occasions where the fuzzy logic can also be applied, it's obviously that there are different other types and different kind of membership functions. So besides knowing what the fuzzy logic is and what the membership functions are and what's their role inside, there's also a fuzzy inference system, which is something to be explained in this whole story of the fuzzy logic. And that's seen or is defined as the process of formulating the mapping from the inputs to an output using the fuzzy logic. And even though I listed it here as a stepwise approach, it is not actually a stepwise approach. It is just here shown in a way so that it's easier and understandable. Its graphical representation can be shown as the image on the right side. So the first step in building any fuzzy inference system is to define the input parameters. So the input parameters are the elements which are explaining our phenomena to its best. These elements are usually precise or crisp values, so the numbers, for example, that are coming from our data. However, this type of information is not of any use in the fuzzy inference system, which is why we fuzzify these crisp elements or crisp values by assigning them already known fuzzy membership functions. Once fuzzified and once assigned with the membership functions, we have to have some sort of rule assignment between these membership functions in order to show or to show the system how to act and what to do with those. So we apply so-called fuzzy rules, which are called if-then fuzzy rules, and the operators which are connecting the first if part with the second and then part, which is basically the consequent of the first if part. And that all goes to so-called the reasoning system or the implication system, which can be or it's called Mamdani or Takagi Sugueno. And those are basically two researchers who explained the functioning of this system for the first time, and who used it or who applied it for the first time. That's why, from where the name comes from. And once that all is being mixed in that reasoning system, some outputs come out. These outputs are again fuzzy sets. And in order to get the output that we can communicate or that we can understand better, we need to aggregate all the output that we get, so all the fuzzy output that we get, in one sort of fuzzy output that usually has to go through one additional step, which is called defuzzification. And defuzzification is nothing else but conversion from the fuzzy set into a crisp, so precise numbers that we can share in sense of numbers or in sense share it on a map or whatsoever, visualize in any way. We will see later on our example how that actually looks like. So knowing now the powerful or how powerful fuzzy logic can be, we wanted to see where exactly we can apply or which fields the fuzzy logic found its application. And as you may see here in this slide, there is a lot in a variety of fields which apply fuzzy logic in its own functioning. And for us, the interesting was the traffic management, where we saw that it's mostly, or it's usually being applied in the signal controls, so basically in controlling the traffic lights, or the accident predictions, or congestion predictions or detections. And this was specifically interested, and we wanted to investigate further how it can find its application here. So in order to investigate further, of course, we had to get to know the traffic congestion term itself, what it is, how it's being defined, how it's being measured, and similar stuff. So we came across so-called fundamental parameters, which are explaining the traffic congestion and which are coming from basic elements of the traffic flow theory, and those are called traffic flow, traffic density, and the mean speed. And the traffic flow is being defined in this sense, is being defined as the number of vehicles which is passing the unit of time. The density is being defined as the number of vehicles which is passing the unity at the specific unit of space. And the mean speed is the average velocity which all these vehicles had at a specific time and at a specific location. And these three elements, called fundamental stream parameters, are connected with this equation. This is really helpful because knowing two of these can help us get the third one. So in order to measure the traffic, or in order to model the traffic, there are certain requests that have to be fulfilled from the modeling point of view. So first of all, these models have to be understandable, have to be unambiguous and credible. They have to have the ability to describe existing conditions and as well as to predict changes, both short and long term. They have to have the ability to reasonably portray
We cannot hear you.
I think we may have lost her.
She's
back. She's back.
Okay.
We lost your audio, Maya.
Hello, we cannot hear you.
We lost your audio. You muted it. Maha, you muted. Okay. You muted again. Oh, good. Please speak something now. We cannot hear you.
We cannot hear you. Maya, we cannot hear you.
it might be possible if you could log it back in again. If you see if that works. We can see your video, nice, your movement, but we cannot hear anything from you.
Hi, Madia, we cannot hear you.
I'd like to ask, have you heard me from the beginning, or it just stopped in some point, or?
I just start from here, yeah.
Oh, it stopped from here. Okay, good, because I've got a short message on the screen that I have to unmute myself, but I also haven't heard anything in between. So I thought I hope it's just not that it happened from the beginning, because that would be bad then. Okay, I'll just continue from now on. Is it okay?
Good.
Okay, good. Yes, I said for the last thing that I said, I think it was that the whole concept of the traffic congestion is being seen as a vague concept, and as such, it requires the modeling to deal with ambiguity, uncertainty, imprecision, and vagueness that come not only from the data, but also from the outer conditions, so from the network conditions, from the road conditions, or from both together. So basically, having in mind that the fuzzy logic is actually capable of addressing these type of issues, and the traffic condition or the traffic congestion deals with these type of issues, our idea was, or we thought of, can these two anyhow be merged, and can we use maybe fuzzy logic to address these issues by applying these subjective knowledge or these linguistic variables instead of traditional analytical techniques? And if yes, how we can do that. So we wanted to see that by using the data that we obtained from one experiment that happened in 2008, and the experiment was conducted on the highway 880 in the California. So we had some data for this 18 kilometers long road highway segment, which had altogether 27 inductive loop detector stations on the whole stretch. So basically here. So these inductive loop detector stations calculated or measured the traffic flow per lane per 30-second time interval, as well as lane occupancy. So having these two information within the data, we were able to extract the traffic stream parameters necessary for our model. And those were the traffic flow, obviously, which was measured already. And from the lane occupancy, we were able to extract the density, which was basically calculated by assuming that every vehicle that was transferring or that was occupying the lanes was of the same length. And this is how our fuzzy inference model eventually looked like. So we had two input parameters, traffic flow and the traffic density, which were crisp or precise values, which, as I already said, are not the values that we can use in fuzzy inference model, which is why we had to fuzzify these two values. And the fuzzification that we made was in a way that we assigned 7 triangular membership functions to both of these two input variables. And for the flow, those were, for example, free flow, reasonably free flow, stable flow, and so on. And for the density, those were low density, medium density, high density, and so on. At the same time, we defined also our output value or our output parameter of interest, which was the level of congestion, also fuzzified with seven membership functions, ranging from congestion-free towards stable, unstable, near congestion, congestion, and so on. So going back to the step number 2 here, once we had these seven membership functions for the first parameter and for the second one, we applied if rules in order to connect these. And after applying if rules and connecting these inputs, we applied implication methods and withdraw the then part of the if rule combination. And once we got all these fuzzy sets that came as a result of this implication method, we aggregated them and eventually we defuzzified them in order to get the values which we can show on the map. So what did we get eventually? This is what we got. We got detected levels of congestions in each lane, so lane 1, 2, 3, and 4. We obviously have a smooth transition, especially seen in the lane 2 and the lane 3, from no to a noticeable congestion in all 4 lanes. What is interesting is that in lane 1, there is a little bit lower congestion indexes in comparison to the other 3 lanes. And what is also interesting is that there is a sudden decrease of flow in the segment 6 in the lane 6. And when it comes to the transition between segments in all 4 lanes, this is also pretty much smooth, except in the lane 1 and in the lane 6, which I already explained. So what does all this mean to us, or what does it tell us, basically? It tells us that the model that we have at this point is the model that does not consider nor it relies on the exact number to derive conclusions. This is meant in a sense that we don't use exact count of vehicles, for example, within the specific road segments that we took into account to imply how congested that specific segment is. It means also that we have the model that is able to address subjectivity, ambiguity, and uncertainties which we encountered in the data, but as well as the road environment. It means that the model facilitates the understanding and analysis of congestion. And why? Because we applied more than one rule to give a composite image, so to speak, of the traffic congestion. And also shows efficient performance and traffic congestion detection possibilities with extremely high noise tolerance. And we noticed that the highly noise tolerance was present in the data. The model is quite simple. It follows common sense, obviously, and it's quite flexible. At the time of writing of this paper, this was our core model, basically, that had only 2 input variables that were equally weighted, even though one of the parameter was measured while the other one was derived from the assumption that all vehicles are of the same length. But the idea that we had at that time that the model can be further extended with additional input parameters and with some maybe more sophisticated rule assignment that we specified for our model. And in that way, that the model itself can have even better or improved performance. And with this, I would finish my presentation, and thank you very much for your attention.
Great, thanks for that interesting presentation and the idea about how to apply fuzzy logic in decision making is a very difficult one. We are so used to see things black and white, and yes or no, and then our policy decision is very much based on that Boolean logic. So the challenge from that to the Boolean world is to say you cannot see the world black and white. You're giving a wonderful decision, a wonderful illustration as to how to use those fuzzy information in policy making and in judgment making. So that is refreshing and then important. We need more work in this area so that we are not being boxed in by a white kind of a philosophy. So with that, I invite our audience to raise the question and discuss with Mahar on this important issue.
So thank you, Maya. I have one question.
Yes.
Yes, first of all, thank you for your very interesting talk. And I think if I understand correctly, before you apply the the logical rule to combine two variables, one of the important step is actually to match the density and also the speed from one segment to your classification, like the flow definition, like stable, unstable, and several rules. So I wonder, since there is a matching from the quantitative information to those categorical information, or this is actually has some order, and I wonder, is that following some domain knowledge or some schema, or is that how do you actually came out that matching?
If I understood correctly, you're interested in how do I extract the information, the traffic information out of the data.
Yeah, you can understand like this way, because you need somehow, right? For example, this is this segment, maybe car moving or maybe 20 kilometer per hour. Another segment is only 5 kilometer per hour, right? So you extract those kind of quantitative information to the labels.
Exactly. So basically, what we do is we chunk either in this case was the just chunk of the road. It can also be the road network. It can be bigger, obviously. So the bigger, the more complex. So what we do actually, what we did here. Let's focus on this example. We had these 6 segments, and we had 4 lanes. So we did it separately. So we have you're extracting the information about the flow from the segment number 1, and the same goes for the density. And that's all being recorded with these induction loop detector stations. Actually, the traffic flow is being recorded or is being measured, while the density is being calculated from the occupancy. And that's what we do from the segment 1, and then the same for segment 2 and the segment 3, and so on and so on. And then you get some values, you get some numbers. And then these numbers, you see how these numbers are being distributed. And you then think about the standards that are, so to speak, valid on this chunk of the road. So for example, let's imagine that the flow, or let's have an example as a flow. The flow for this chunk of the road would be 6,000 vehicles per hour, which will give 1,500, around about 1,500 for each lane, which will give in 30-second interval only 13 vehicles. And then the 13 vehicles would be the standard, for example, for that chunk of the road. And then I have my numbers, which are valid for each of my segments. So I have the standard and I have my distribution. And that's how I create the rule based on the distribution of the data that I calculated.
Okay.
If I got the answer on the question properly.
Okay.
Yeah, I think. Yeah, thank you.
Good.
So, do you have a follow-up question or?
No, I was just thinking different type of roads may have different, criteria to determine those categorical labels. So yeah, I would be interesting to see more different testament. Yeah.
Great. Shin, I see you turn you on, so I assume you have a question.
Yeah, thanks for the very inspiring, very inspiring work. Yeah, I forgot to introduce myself in my last question asking. Yeah, my name is Shin Shi. I'm from Dartmouth College in the United States. I just have questions on two specific issues, maybe just a quick question. So on one of the slides, you mentioned this systems called the Sugino and Mamadani systems. Yeah, I am not familiar with these. Are these specific fuzzy logic systems, or so if you can elaborate a little bit, that'd be great. And the second question is one of your almost to the end of the we're talking about advantages or implications of this fuzzy system. You said it can possibly with it can efficient performance and traffic congestion detection possibilities with extremely high noise tolerance. I'm just if you can elaborate that a little bit, I would appreciate it. How this fuzzy system is advantageous in dealing with extremely high noise. That'd be great. Thank you very much.
Thank you very much for the question. When it comes to the first question, Mamdani and Sugeno, as I think I mentioned that during the presentation, but maybe that was when I stopped or when you stopped, when you couldn't hear me. So Mamdani and Sugeno, those were two researchers that I think explained the functioning of the system in 1973 or 1980, so in between, so around about 1980s. So basically, they applied the fuzzy logic as the theory was known even before, but then they applied basically for the first time one such system in order to automate one process that they were dealing with. That didn't have anything to do with the traffic nor with anything else, but rather they built the system and applied it to a automation of some process. And they explained how the system is functioning, how all the technically how all the steps are working, and that's why the reasoning scheme is basically named based on them. Okay, and yeah, that's the when it comes to the first question. And when it comes to the second question, yes, I use a little bit hyped words here because the data that we worked with, this was really a small chunk of data. So I had a little bit bigger data set, but the data set itself was not so friendly, let's call it so. It was really, really missing a lot of data and really a huge, so to speak, gaps between the data, which I did not want to apply for the first time in my model because I thought maybe the model is capable of dealing with such strong or with such bad data, let's call it so. But let me see. Let me first take a smaller chunk of data, and this was I think from 6 to 9 p.m. In few days. So the time slot was few days, but the same every day was from 6 to 9. So basically, it was not the peak hour. It was nothing specific that should happen at that time. But luckily, we had the ground truth data as well for this, and this was really nice that we could compare basically what we got with the ground truth data. This was not something that I put in the paper because I didn't have the ground truth data for every day, only for one day. So I didn't want to make my conclusions based on only one day, and I had the data, or I had used the data for all 3 days. So yes, that's why I use these words, because in general, the data set was pretty much noisy, so to speak. And I've noticed that the model, or not noticed, but I kind of like concluded that the model is capable of dealing with this type of data, which is why I use these hyped words to emphasize that even more in a conclusion. Yeah.
Great.
Thank you very much.
Great. We are right at the time that we scheduled to. So, Mahav, thank you very much for the interesting talk. And then we are very happy that we be able to keep in this time allotted. And then I want to invite Dr. Sumin Bao to present, to give a summary comments, a concluding remarks.
All right, thank you. Thanks for everyone, all the speakers and presenters. So congratulations to all the best paper authors. So I've been working with CPGIs, the AGIs from the very beginning. And I serve as General Secretary for the headquarters of the CPGIs. And also I handle the routine operations. And the journal of the Annals of the GIS started from the journal of the GIS. It's founded actually initialized by Professor Peng Gong at Berkeley. Now he's the vice president of the University of Hong Kong. So then in 2010, the JGIS and transferred to the Tanner publications. So started the Professor Hui Ning, then was a chief editor for the Annals of the GIS, and then Professor Axin Zhu then take over a couple of years ago, so as a chief editor. So the AGIS we have been see the AGIS keep growing and have made a great achievement and in the recent years. So we expect the AGIs will be successful and be a SCI, the indexed journal paper and journals in the near future. So congratulations to everyone. The China Data Institute is actually inherited from the China Data Center at University of Michigan. So I was in Michigan as a faculty member of the University of Michigan from 1996 to 2018. So the China Data Institute now is a separate operation from the University of Michigan. Its mission is basically the same as similar to the CPGIs, try to promote spatial temporal data analysis and also its applications. And we have been worked with Wuhan University and Harvard University, and recently on the spatial data lab project, and also try to promote the spatial data analysis, especially in the COVID-19, the data analysis. So we have try to organize a team, international team, to make some COVID-19 the research data available on the Harvard Dataverse for public sharing for research. And also we have been organized a series, the training webinars for COVID-19 data analysis. So we have organized the primary series in this from June and July. We are going to have started a third series of the webinars on the impact analysis of the COVID-19 in next January. So we are being worked with, so today I see there's many good papers. What we're like to try to do, we're trying to make those research not only have the good publications, but also we're like to promote the replicable and reproducible and expandable research. That means all the data or the data analysis procedures can be replicated and reproduced by others. So then we can expand the research and by the people across the world. So we'd like to work with the teams, those others here, probably to use the workflow and to make your work and more producible and also replicable by other people. And so your research can be applied by the more people. So from the this September, we have also organized a series, the monthly training webinars on research data, on also workflow. So this is kind of the topic we have covered from the statistics data, sense data, economic data, population data, and pattern data, health environment, and urban and rural the data, different topics, almost cover all the different kind of the data source. And also, we also offer a monthly training webinars on the workflow-based data analysis. This co-sponsored with RMDS lab at California. So this workflow-based data analysis is based on the publications. So we developed workflow, try to replicate those data analysis and in those publicate the papers. That's what we are doing, and this is our website for CPGIs, for China Data Center, and also for Future Data App. As I just mentioned, we're like to work closely with Professor Axin and also with Annals of GIS and try to make those future publications and more producible, more replicable, and also put all the data and workflow and also PPT shareable with the authors and also the readers. And we'll see the future progress by under leadership by Professor Ashing Zhu. Thank you very much.
Okay, great. Let's turn on the radio and video. We can take picture together. Particularly the presenters, if you could turn on your video and then let's have a picture together, right? I hope it's too late in China. One of the presenters may have left because it's about it's about 2 o'clock in China right now in the morning. So anyway, so what we can, and the co-authors, please also turn your videos on, and also audience, just turn your video on and we can take a picture together. We have a specialist that is can help us to take a picture, and then I'll send around to you guys, right? Anybody else? Please turn on your video so we have a picture together, right? While we're doing that, I want to say that today has been great success thanks to the presenters, not only for that effort of presenting, but all the effort in the excellent work. The 3 papers represent 3 different important issues that we need to address in GIS science. One is finding data for the model. The other one, the role of geography in policy making. The third one, how we can help us to make a decision in a more scientific, quantitative way, which are really the issue that we are facing. So, which is excellent. I myself learn a lot, so I appreciate it. So that I hope that picture being taken, and I also thank the audience for sticking around for this long, and then also for the questions. And certainly thanks goes to the presenters for that great effort. Congratulations and thank you. You all have a wonderful day. I do not know what time you are at each places, but I would say have a good day. Well, it's about rather Australian language, but nevertheless, it's a better way to describe to you all to have a wonderful time. Thank you.